Circle theorems. In this video, I will discuss tangents and radii meet at 90 degrees and tangents from a point have equal length. Let's label the parts of the circle. So in this circle, this edge is called as the circumference. And this is a chord of the circle. This is also another chord. And the two chords meet at this point and it creates an angle. This chord is created from the arc CD. So this purple shade is the arc which has created the chord to the circumference like this. So let me label it chord, angle, chord, and this is the arc. Okay, now look at this circle. The center is marked. And this is the radius of the circle. So you know that the radius of the circle is equal. I will mark it. The two radius are equal. And I will join it with a chord. Then I create an isosceles triangle. So in an isosceles triangle, you know that the two angles which I have marked, that is this and this, are equal. As well as we know the interior angles of a triangle is 180. So these are the foundation or the basic things that you have to know when you are doing a circle theorem question. So continue. The circle, I'll mark the two radius and I have marked it as equal. And this is the chord. So it created an isosceles triangle. Also, these are the tangents. This is a tangent. So tangent is the line drawn external to the circle which touches the circle at one point. So you can see the radius has touched the tangent over here. The angle that is created between the radius and the tangent is a right angle which is 90 degrees. So you can see this is the radius. This is the tangent. Tangent and the radius has created 90 degrees. I repeat, it starts with radius, it's moved and come down to tangent. So radius and the tangent create 90 degrees. Then the circle theorem over here, the angle between a tangent and a radius is 90 degrees. You can see in this figure, this is the radius, this is the tangent. Tangent is the line which is drawn external to the circle, which touches the circle at one point. So this radius and the tangent has created 90 degrees over here. It is explained in both the figures clearly to you. If a tangent line, a radius and a circle all intersect at the same point, the tangent line and the radius will be perpendicular. Perpendicular means 90 degrees. So the same thing is explained again. You can see the radius. This is the radius. This is the tangent. Tangent and the radius together has created 90 degrees. Look at this figure. Now we are going to practice a small question. You can see the radius and you can see the tangent. This is the radius, this is the tangent, and I have completed a triangle using another line. So radius, tangent, and then here I have completed the triangle. So what we know out of what we learned so far, the radius and the tangent creates 90 degrees. So this is the radius, this is the tangent, together it creates 90 degrees. Angles in a triangle adds up to 180 degrees. So we know two angles, which is 67 and 90, that adds up to 157. From 180, when you subtract 157, this angle is 23. In this figure, the first thing I did, I have marked the radius. When I mark the two radius along with this chord, this is an isosceles triangle. In this video at the beginning, I explained you, in an isosceles triangle, this angle over here and the angle over here are equal. Angles in a triangle adds up to 180 degrees. From that, the angle given 125. When we subtract, we get 55. And let's divide it by 2. So each angle is 27.5. Nextly, we learned a circle theorem that the radius and the tangent creates 90 degrees. Radius and the tangent are perpendicular, which I have marked in yellow shades. So if the angle between the radius and the tangent, that means from here to here, it's 90 degrees. And the small angle over here, it's 27.5. Then from 90, when we subtract 27.5, angle B is 62.5. Look at this figure. So we know this is the angles on a straight line, which adds up to 180 degrees. From 180, when you subtract 120, that is over here, you can get the angle C first, that is 60 degrees. Then I will refer to this triangle, which is an isosceles triangle, because this is the radius and this is the radius. Angles in a triangle adds up to 180. From 180, when we subtract this 120, which is within this circle, we get 60. And we divide it by 2 for you to work out each angle. So we got it as 30. And then we can see the tangent and the radius. Nextly, this is the radius and this is the tangent. Tangent and the radius, it's perpendicular. It creates 90 degrees. You can see this is another triangle, which one angle is 60, the other angle is 90. So angles in a triangle adds up to 180. Missing angle D is 30 degrees. I have shown you the workings. From 180, we subtract 90 and 60 together, which is 150. The missing angle D is 30 degrees. Two tangent theorem. So in this case, you can see I have shaded in pink the two tangents, and both the tangents have started from the same place. So they are equal in length, as well as when it meets the radius, it creates 90 degrees. Radius and the tangent together create 90 degrees. Look at this example. So you can see AB and AC are the tangents. They are equal in length. OB and OC are the radius. So the tangent and the radius will create 90 degrees. And the angle BOC is 120 degrees. So each angle is then 60 degrees. If this is 90, this is 60, the angle X is equal to 30 degrees. 120 we divided by 2, that is because the angles bisects. So each angle is 60 and the angle x is 30. And then they say the radius is 3 centimeters and they say the tangent AB is 4 centimeters. I want you to find the length AO. So you can see this is the right angle over here. Therefore, this is a right angle triangle. ABO is a right angle triangle. ABO right angle triangle, angle B is 90 degrees. The side facing the angle B is AO, which is the hypotenuse. You know, we will use Pythagoras theorem. We use Pythagoras theorem to find the lengths of the sides of a right angle triangle. So you want to know the length of hypotenuse. We can use the golden triangles, which you call it as 3, 4, 5 triangles. So if this is 3, if this is 4, so the hypotenuse is the longest side of the right angle triangle. It is 5 centimeters. In the next slide, we will discuss about the angle at the center is twice the angle at the circumference, and also angle subtended at the circumference by a semicircle is 90 degrees. So in my next slide, we are going to learn about these two circle theorems.